I'm going to show you how to solve this differential equation by separating the variables. Notice that extra information is given about x and y, so I will end up having to find the particular solution. So before I can separate the variables, let me shift this to the right. So now I'll start to separate the variable. I'm going to take all the y terms and move to the left. I see a y term here. I see a y term here, so I divide over. And this dy will stay here. And then I'm going to take all the x terms and move to the right. So I have a negative x squared here, followed by a x minus 1 dividing over. And dx goes over. So now I'm going to integrate both sides. Now if you look at the left hand side and the right hand side, both the rational expressions are improper. So I have to do long division to re-express this as proper rational expressions. So this means to take y squared divide by y plus 1. So y squared into y squared divided by y is y. Distribute the y, so y times y plus 1 gives me y squared plus y. So I'm going to take y squared minus this. Y squared minus y squared cancels out. So I'm left with negative y. Continue again. Negative y into y. Negative y divided by y gives you negative 1. Now negative 1 multiplied to y plus 1. I have negative y negative 1. So take this minus this. Negative y minus negative y cancels out. So I'm left with positive 1. So now I can rewrite this improper rational expression as this whole or quotient plus the remainder divided by the divisor. So I'm going to do the same to this improper rational expression. I'm going to take x squared and divide it by x minus 1. So x squared divided by x, I have an x, and then multiply to x minus 1, I have x squared minus x. So take this term minus this term. X squared cancels with x squared, I'm left with a positive x. So now x divided by x gives me a positive 1. 1 times x minus 1 gives me x minus 1. So take this minus this. X and x will cancel, I'm left with a positive 1. So now I can rewrite this improper rational expression as the quotient plus the remainder over the divisor. So now I can attempt to integrate all the terms. Integrate y is y squared over 2. Integrate 1 with respect to y is y. Integrate 1 over y plus 1 is ln. Integrate x is x squared over 2. Integrate 1 with respect to x is x. Integrate 1 over x minus 1 is ln. And plus c. So now I'm just going to arrange them a bit. So since this whole term is negative, I will move all of them to the right. So negative x squared over 2 move to the right, become positive x squared over 2. And I write this term here. Negative x move over, become positive x, and I'll write this term here. And negative ln x minus 1 move to the right, become positive ln x minus 1. And this term. And all of them is equals to just c. So this is my general solution. Now, I'm supposed to find particular solution given when x equals to 0, y equals to 0. So let's sub all these values. X is 0, y is 0, x is 0, y is 0. So x is 0, I have ln of negative 1. And y is 0, I have ln of 1 plus c. Now ln of absolute of negative 1 means it's positive 1. So this one is positive 1. So ln of 1, if you press the calculator, or you already know, is 0. Ln of 1 is 0. So I made a mistake here. It should be equal. So with that, I can tell that c is 0. So with c is 0, I just have to rewrite this whole expression again, where c is 0. So if this half and this half bothers you, you can multiply the whole expression by 2. But I will just call this my answer. This is my particular solution.